This is Dr. Lata, Assistant Professor, Department of Physics, Dr. MGR Educational and Research Institute, University. In today's class, let's explore on a unique property of a liquid, that is viscosity. Basically, liquid is a substance that can flow. Liquids, they do not have a definite shape and they take the shape of a container and they are incompressible. Apart from such properties, they also possess peculiar properties such as surface tension. You can see on the colorful picture where the drop of water found to be almost spherical in shape, and that is because of the intermolecular interactions between the water molecules, which makes the water molecules to be bound to a surface. And second is a photograph of a person who is swimming and he is completely enveloped by a glass of water, the phenomena which is exhibited by a surface tension. Another property of a liquid is a capillarity, which is a phenomena of a rise of liquid in the narrow tube, is a capillary action. The interesting property of a liquid is viscosity. Let's explore viscosity in detail. Viscosity of liquid corresponds to the concept of thickness of a liquid. Example, syrup, which has a higher viscosity than water. Now we can very well look at the flow of different types of liquids, right from the tap water, honey, gel like liquid and oil. Now viscosity, which is a vital factor which determines the energy required for all these types of liquids to make them to flow. That is, viscosity is the result of interaction between the molecules. Viscosity is not the phenomena that takes place inside the textbook. It happens in the day-to-day life. And now you come to the first example, which is the engine oil. We should be aware of viscosity of engine oil because it affects the friction and it also affects the heat in the engine. That is lubrication. Viscosity is the most important characteristics of a lubricating oil. Now you come to the second example where it is the shaving cream and the third one is the paint. Now in case of paint or shaving cream or any lotion, viscosity is the measure of how resistant a paint or a lotion is to spread. Okay, how smooth it spreads, how uniform it spreads, that property is revealed by viscosity. Now even in the food items such as ketchup or honey also depend upon the viscosity for its spread. Viscosity can be of critical importance in case of medicines such as syrups. Now we can see on the down there are so many examples like saliva. Even saliva also possesses viscosity. The blood viscosity is a major issue. Blood that is too viscous can form very dangerous clots, and when it is too thin it will be runny and that also causes the loss of blood. And vitreous humor is a liquid which is found in our eye, and the last one is a synovial fluid which is found in our knee joint. So all these types of viscosity, the human body viscosity plays a major role in our healthy life. Now at the picture you can see a dazzling flow of honey, and the right side you can see very well you can view the different types of liquids with different viscosities. So we can conclude here that a fluid with low viscosity is said to be thin, while high viscosity is said to be thick, as honey is thick. So it is very easier to move through a low viscous liquid than a high viscous liquid like honey. Okay? Or in other words, we can say that a frictional force between the molecules is much higher in a high viscous liquid than in the low viscous liquid. Now, suppose imagine that we move our fingers through water contained in a tank. Obviously, we experience a resistance, right? This shows that water offers a frictional force, which is then termed as a viscous force. Now, let us consider a steady flow of liquid through a fixed horizontal surface. So, look at here. This is a fixed horizontal surface through which we are considering a steady flow of liquid. So, for our easier purpose, let us divide the flow of liquid into different layers. So, we have marked the layers as, named the layers as 1, 2, 3, 4, 5 and 6. Now, look at here. The first layer, which is at a distance x, and the second layer will be at somewhat higher distance from the surface, and third layer will be much higher distance than the second layer, and so on. Okay. Likewise, let me take the first layer. The first layer will be traveling with lower velocity, otherwise I can say that the velocity of liquid layers will be almost equal to 0, that is V is equal to 0 at very close to the point. That point is also called as point of contact. Okay. So, now the second layer will be traveling with much more higher velocity than the first layer, and third layer will be traveling with the higher velocity than the second layer. Likewise, fourth layer will be traveling with progressively higher velocity than third layer. Likewise, fifth layer and sixth layer will be traveling with progressively increasing velocity, and sixth layer will be at its ultimate velocity. So, as we come across the layer from the first layer to the sixth layer, there is a difference in velocity as the distance from the fixed surface increases. Okay. Now, here we can say that this involves two parameters. One is the distance and the other one is the velocity. So, there is a relation between the distance and the velocity. As the distance from the fixed surface is increased, the velocity also increases. As the distance from the fixed surface is decreased, velocity also decreases. Okay. So, now this difference in velocity with respect to distance is taken as the term gradient. Gradient is what? The variation. So, the variation of one quantity with respect to another quantity is called as a gradient, and here it is called as a velocity gradient, which is the variation of velocity with respect to the distance. Okay. This plays a major role in the flow of a liquid. Now, come back to the friction. As different layers are traveling with different velocity, there will be fast moving layers as well as the slow moving layers, and there will be a frictional force or a fighting force will be created between the fast moving layers and the slow moving layers, as a result which results in the friction between the liquid layers, and which resists the flow of liquid towards the force. Okay. Now, mathematically, from the Newton's law of motion, this can be represented as look at here. This can be represented as the viscous force, which is proportional to A, is the area of cross section of the layer, into dV by dx, which is the velocity gradient. Now, this proportionality sign is replaced by means of equality, equal to sign, and hence we get a constant, and that constant is termed as a coefficient of viscosity. This term is called as a coefficient of viscosity. Now, we will come to the definition of how to arrive at now look at here, how to arrive at the definition of eta, that is a coefficient of viscosity. Here I can say that the viscosity, the coefficient of viscosity on left side, which is equal to minus F divided by A into dV by dx. That is, we have introduced a negative sign. The negative sign is because as the flow viscosity opposes the flow of liquid, we have indicated that with the negative sign. And now the definition can be obtained very easily when we consider this A as unity and dV by dx is taken as unity. That is, area is taken as 1 meter squared and velocity gradient is taken as 1. Now look at here how to arrive at the definition. The coefficient of viscosity is defined as the viscous force, is defined as the coefficient of viscosity is defined as the viscous force per unit area, since A is taken as 1 meter squared per unit area to maintain unit velocity gradient. That is the definition for coefficient of viscosity. Now there are two types of motion of a liquid. One is the steady flow and turbulent flow. Look at the picture. The first picture shows that the liquid is flowing in the same layers. The liquid is flowing in layer by layer. Whereas in case of the second picture, there is a turbulent flow. It's a mix of layers. Okay. Now with the microscopic level, we can explain the turbulent flow and the streamlined flow, which is also called as a laminar flow. That is, all the particles inside the laminar flow, they travel with same velocity along the same direction. Whereas in the turbulent flow, they travel with different velocity in the different direction, and they sometimes even causes a whirlpools, that is eddies. Okay. Now as we see here, the turbulent flow and the laminar flow can also turn into a turbulent flow at a crucial velocity, that is a critical velocity. That velocity is termed as a critical velocity, and that can be given by the term Vc is equal to k eta by rho into alpha. Now that k is a Reynolds number. Reynolds number will give you what type of flow are they, whether they are streamlined flow or the steady flow. Okay.